Hello, this lesson is on Unit 4 Standard 4, which is the mean value theorem and also Rolle's theorem. So this, you see two pictures here on your notes, and I'm going to focus on one of them. This is the general theorem, and Rolle's theorem is actually an applied version of the mean value theorem. The mean value theorem states that if you have a continuous function on a closed interval, and you can take the derivative anywhere in that interval, or there's a slope everywhere at that particular function, then there has to be one value, c, which is an interval, such that f prime of c equals fb minus fa over b minus a. And some of you are saying, what does that mean? So to make a long story short, what this really means is that this is saying that there has to be, if I take the slope of the whole interval, okay, take the beginning and the end, I take the slope. If I take the slope, for example, here's A and here's B, and I take the slope of the whole interval, there has to be another point in this interval. In this case, maybe it's right here. There has to be another slope or another point in this interval that has the exact same slope as the whole thing. Or another way to put this, I tell my classes every year, is think of this way. The slope is kind of like the average. What we're trying to say here is that the whole average, if the average is like 5, there has to be a point in the interval who also has a slope of 5. Or another example I do in class is like, say for example, I take the average weight of everyone in the class. And let's just say the average weight in the class is 100 pounds. By mean value theorem, that says that if the average is 100 pounds, that means there has to be someone in the class that is 100 pounds. For mean value theorem, what I'm saying is that the slope for the whole thing, there has to be a point that has the exact same slope as the whole interval. Now, Rolle's theorem here on the right is a specific case of MET. What this means is it's exactly like mean value theorem, except for if it's continuous and differentiable, same two prerequisites, but if f of A is the same of f of B. Or in other words, if the slope is 0. So you pick an interval and the average slope is 0, then there has to be a point whose slope is also 0. So in this particular case, you see here the interval, the average over the whole thing is 0. There has to be a point in this interval that also has a slope of 0. So that's mean value theorem, that's Rolle's theorem. I think it's very easy to understand. That's why I'm teaching this over video. So here are some examples. How can they ask you this on the AP exam? The instructions say determine if the mean value theorem and or Rolle's theorem applies to the function in a given interval. If either applies, find all values of c that are guaranteed by the theorem. Well, here you go. First of all, I look at my prerequisites. Is this continuous? Well, this particular function, you can put it in your calculator, but I know it's continuous because if I put in any number from 1 to 5, there is a value. It wouldn't have been continuous if I put in 0, because if I put in 0, I get if I put in 0, I would get a -1 underneath the square root sign, which is undefined. So this is a continuous and differentiable function. So let's just see, or let's find out, what is the average slope of the whole function. So let's try again, f of b minus f of a over b minus a. I'm just going to flip the formula real quick, equals f prime of c. Or in other words, there has to be some number that has the exact same slope as it. So what I'm going to do is I'm going to plug in the formula on the left. So if I put f of b, which is the same thing as plug in 5 into the formula, I'm going to get 4 plus the square root of 4, I get 6. Okay. If I plug in 1, I'm going to get 4. Okay. B minus a is 5 minus 1, because that's our interval. I get 4. So the slope over the whole interval is 1/2. The average slope is 1/2. So what I'm trying to say is that there has to be a point whose derivative is also 1/2. How do you figure out what that point is? Well, what you do is you take the derivative of the function, okay? Because this is f prime of c. So what I'm going to do is I'm going to take the derivative of f of x and plug in c. So this particular case, the derivative of 4 is 0. Derivative of x minus 1, some of you don't know what the derivative of x minus 1 is, so I'll convert it into x minus 1 to the half power, which is half x minus 1 to the negative half, or 1 over 2 square root of x minus 1. Okay? So basically what I'm telling you is that there has to be, I'm going to plug this back into my formula, 1 over 2 square root of c minus 1. There has to be some number that that if I plug c, that would give me the exact same answer as 1/2 for the whole thing. So all I'm going to do is solve for c. You'll notice that the numerators are already equal to each other. 1 equals 1. So I'm just going to set the denominators equal to each other. So 2 equals 2 square root c minus 1. I'll divide both sides by 2, which gives me 1 equals square root c minus 1. I'll square both sides, which gives me 1 equals c minus 1, which means c equals 2. So what I just found is a point in the interval 2 that has the exact same slope, 1/2, as the whole interval. Okay. We're just going to do one more, so you kind of get the point. I'm going to erase this real quick. Sorry. Now, this particular problem, same thing. I have a function, and I have an interval. First of all, let me see if it meets the criteria. If I plug in 0 or plug in 4, I will get a regular function. And yes, this is differentiable. I can take the derivative of this. So I'll write down my formula again: f of b minus f of a over b minus a, which is exactly just the slope formula, equals the derivative at some point, at some number c. So what I'll do is, again, I'll plug in 4. In this case, I plug in 4. I'm going to get 2 minus 2 plus 3. So I get 3. If I plug in a, which in this case is 0, I get 3. 4 minus 0, I'm going to get 0 over 4. 0 over 4 is 0. So this is actually Rolle's theorem. When I plug in both numbers, 0 and 4, I get a slope over the whole thing as 0. So this tells me there has to be, if I take the derivative, there has to be some number that if I set it equal to 0, that has the exact same slope as the whole thing. So what I'm going to do, again, is I take the derivative, which in this case is half. This one, square root of x, you may not know, so I'll do a little side calculation, x to the half, or 1/2 x to the negative half. So this is going to be minus 1/2 x to the negative half. And the derivative of 3 is 0. So all I do is I set the left side equal to the right side, and remember, I'm solving for c. Let me rewrite this so it's a little bit easier for you to understand. Something very similar we did on the last problem, over 2 radical x. Oh, in this case, sorry, c. Okay. So now I need to solve for c. There has to be some number. To make a long story short, you could solve this algebraically. You can figure this out. Some of you that are bright enough, you can tell that if I put a 1 where there is c, I'm going to get half minus half equals 0. The answer here is 1. So I found a number c, or what I'm telling you is that there is a number 1, okay, that is in the interval from 0 to 4, that has a slope of 0, which is the same thing as the slope of the whole thing. So that's all you need to know about mean value theorem and Rolle's theorem. Again, it's very simple. All you do is plug it into the formula and find, again, the number in which has the exact same slope as the whole interval. If you have any questions, you can see me or ask me in class. Other than that, I hope you enjoyed the video, and I'll see you all later.